Adding a few more details, we know that solutions we talked about in terms of wind, solar, renewables, the innovations needed in buildings, heating and cooling, construction, transportation, agriculture, etc. are going to take time, and adopting those technologies into societies also involve many barriers, but there is nonetheless the urgency of action for adaptation as well, and this is especially critical for countries that are called atoll nations, which are facing not only a sea level rise like sitting ducks, but also other issues of acidifying oceans, losses of corals, fisheries, fishing pressure, etc. So low-lying atoll nations are especially threatened by climate change, with many islands mere meters above sea level and subject to more frequent and intense extreme events. Mitigation is critical for survivability of atoll nations. At the same time, ambitious adaptation actions are needed to prevent them from becoming uninhabitable. Several atoll nations like the Republic of Marshall Islands, Kiribati and Maldives are protecting their coastal areas by planting mangroves, restoring wetlands, improving water systems. These are called natural solutions. We will come to it a little bit later. However, higher temperature scenarios will limit the viability of these actions. So what if mangroves just don't manage to survive when acidification and warmer temperatures make it impossible for them to survive? Some may follow the lead of Kiribati, which purchased land in Fiji as a way to proactively plan for managed retreat. So literally they are thinking about moving. Others, like the Marshall Islands, may commit to remain and look for ways to build higher islands. So there are many other questions. As the sea level rises, does your exclusive economic zone sink from the boundary? It's considered 200 miles in every direction. If your coastline moves, then what happens? So those are very complicated issues as well, in addition to attributing the cause of climate events. Nonetheless, this report focuses on the triple dividends we talked about and benefits and costs of illustrative investments in adaptation. So this is an interesting calculation which puts things in perspective. So looking at these 5 things we mentioned, strengthening early warning systems for disaster management. Cost-benefit ratios are shown here in terms of investment and net benefits. So 1:1 to about 12:1 here. So you can see that this early warning system stands here at 9:1, so a net benefit. So this is considering a net investment of 1.8 trillion in 5 areas. The total does not equal the sum of the rows due to rounding, so there are some details. So the graph is just meant to illustrate the broad economic case for investment in a range of adaptation approaches. Okay. Actual returns will obviously depend on many factors such as economic growth and demand, policy context, institutional capacities, and condition of assets. So whenever you do future projections, especially economic benefits, returns on investments, that's going to be dependent on many factors. Okay. Also, these investments neither address all that may be needed within the sectors. For example, adaptation in the agriculture sector will consist of much more than dry land crop production, which is considered here. Not include all the sectors, as health, education, and industry sectors are not included. Due to data and methodological limitations, this graph does not imply full comparability of investments across sectors and countries. Nonetheless, it gives you a sense of the dividends one expects in terms of at least reducing loss of GDP with climate impacts getting worse over time. So, strengthening early warning systems, net benefit of 0.1 trillion, making new infrastructure resilient to climate impacts, especially extreme events, 4 trillion, improving dryland agriculture crop production, 0.7 trillion. We talked some of these in the other books we have considered. Protecting mangroves, $1 trillion. We talked about briefly blue carbon economy, which is also part of this natural solutions. Mangroves obviously improve habitats, oxygen, biodiversity, storm damping, inundation reduction, filtering of land pollution as it goes into the open ocean. Many livelihoods depend on them, and so on. Making water resources management more resilient, 1.4 trillion. So a total of net benefits of investing in these five sectors is considered at $7.1 trillion in total. So the basic elements, the adaptation typically is a very regional and local issue. Depends specifically on what type of climate, what kind of land, what level of sea level rise, what kind of extremes you are dealing with, and so on. So regional, local, specific information becomes very critical. In fact, one of the big criticisms about CMIP and IPCC projections is that they are good at global level, but their region specificity and accuracy at local levels tends to be low, even though it's getting better, especially in terms of temperature, but not so much in terms of rain and other sea level rise, for example, and so on. Nobody lives in a global mean temperature, global mean sea level, for example, which is always said. So we need very local information. Nonetheless, we can look at some typologies of climate change adaptation. Includes reduce and prevent, prepare and respond, restore and recover. So this is agriculture, research and development, climate proofing buildings and infrastructure, land use planning, nature-based solutions to protect people and assets, permanent relocation, which is now becoming probably more and more obvious, especially for some of the island states that we mentioned. Prepare and respond, so early warning systems, forecast-based action, contingency planning, strengthen first responders and temporary evacuation. So you can see that these timescales are much shorter. There is the decision horizons on infrastructure, energy, and so on, which are, let's say, decades to multi-decades, where these are managing immediate events. Restore and recover, insurance and risk finance instruments, so make climate risk a part of every decision on agriculture, crop selection, infrastructure, energy, health, water management, and cities, etc. Social safety nets, recovery services, including health and education. Build back better. So every time you have a disaster, you build back by keeping in mind the climate risk. Talking about risk, the World Economic Forum puts out a global risk report every year, and it surveys a number of groups, as I will show in a minute. So I just want to point out that they look at economic, environmental, geopolitical, societal, and technological risks that people perceive, so the number of respondents there. So COVID obviously has affected this 2021 report. Infectious diseases are here at the top. Livelihood crisis and extreme weather events, and then there are a bunch of others here, including human environmental damage here. But if you look at the evolution of these risk assessments by people, top global risks by likelihood in different years, you can see that from 2012 onwards, 2017 began to put extreme weather as first in global risk by livelihood. There are other ways to look at it. I just picked this one. And you can see that extreme weather has topped it, and then second has been natural disasters and climate action failure, human environmental damage, and biodiversity loss, and now infectious disease, and so on. So tells you that people are beginning to experience and then put them in their list of risks. These are the people who are typically surveyed, survey sample composition in terms of gender, expertise, organization type, age distribution, and regions. So it is a fairly comprehensive global survey, and always provides a good guidance about where people are going in terms of their experience and their risk perception. It's a question of how to convert that into action in terms of investments, policies, and individual behaviors as well. And there are always barriers to adaptation, which could be institutional, understanding, awareness, finance, adaptation capacities, and so on and so forth. This paper talks about the dynamic interactions between them. So limited awareness can affect public support, which can affect impediment to learning, which can then affect slow awareness rising, so it can become a vicious loop. You have to find a way to convert that into a virtuous loop. Okay, so let me come back to more details in the next podcast, but you get a sense that adaptation is something that is required and directly relates to reducing vulnerability and increasing resilience of infrastructure, agriculture, water, disaster management, and various other sectors.